Okay, we're going to do 2,6 and 2,7, which is graphing rational functions. Okay, so a rational function looks like f of x equals n of x over d of x. It's like some polynomial over some polynomial, okay? So it's like fractional, okay? There are like, I don't know, 10-ish steps in order to graph one of these by hand. Now keep in mind that we only have one test coming up. There's no quiz on this section. There is also no graphing calculator on this next test because it's graphing by hand, okay? So we're going to go through the steps now. There are a lot of them. The first one is to find the whole. Okay, so to do that, you're going to factor the numerator and denominator and cancel a common factor. If that happens, then you know there's a whole. And so to find it, you're going to use the x value to substitute into the simplified rational function and find y. Some. Okay. Step 2. We're going to find the y-intercept. Now you know how to find the y-intercept, right? Plug in 0 for x, solve for y. Easy. Step 3, find the x-intercepts. Now remember that x-intercepts can also be referred to as zeros or roots. And in that case it would just be like x equals rather than an ordered pair. So to do this, you're going to take the numerator, you're going to set that numerator equal to 0 and solve. Step 4 is to find vertical asymptotes. And we're going to just refer to this as VA because it's way faster to write. Okay, so VA is going to stand for vertical asymptotes. So a vertical asymptote is a vertical line that the graph never crosses. It's an x equals equation. And to find it, you set the denominator equal to 0. Step 5. Find the horizontal asymptote. Okay, or HA. The horizontal asymptote is a horizontal line that the graph usually doesn't cross. It's a y equals equation. To find it, you have to follow some rules. Okay, so these rules you're going to have to memorize. So here they are. For f of x equals n of x over d of x. So you have some polynomial in the numerator, some polynomial in the denominator. What you're going to do is you're going to look at n, which is going to be the degree in the numerator. And you're going to compare it to m, which is the degree in the denominator. And if n is less, well, let's say if n is less than m, so if the degree in the numerator is less than the degree in the denominator, then there is a horizontal asymptote at y equals 0. Okay, so let me show you what that looks like.
Sorry, what? Like it's e.
M is the degree in the denominator. It's just d of x. It's
Oh,
like
okay.
the polynomial in the denominator. Yep. So for example, if you have like 2x squared minus x over 3x cubed plus 4. You look at their degrees in the numerator and the denominator, and in this case 2 is less than 3. So if the degree in the numerator is less than in the denominator, then you have a horizontal asymptote at y equals 0. Rule 2 says if n is greater than m, then there is no horizontal asymptote. Okay, so for example, if you had like 3x to the 4th minus 1 over 2x squared. Then here the degree in the numerator is greater than in the denominator, so there isn't going to be a horizontal asymptote at all. Okay, there's none there. And then finally, if n is equal to m, then the leading coefficient determines y equals a sub n over b sub m. Let me show you what that means. So for example, if you have like 4x cubed minus x over 2x cubed plus 1, let's say. So looking at the degrees, they're the same. When they're exactly the same, then you look at the leading coefficients of those terms. So then your horizontal asymptote would be y equals 4 over 2. So then your horizontal asymptote would be y equals 2. Okay, you just look at the degrees. If they're the same, then you're comparing those leading coefficients, creating that fraction, simplifying it, that's your horizontal asymptote. So you have to memorize these rules. Moving on. Ready to move on? I gotta turn the page. Okay. Step 6. You need it still? So step 6 is to find slant asymptote. Or SA. Okay, so if the degree in the numerator is exactly 1 greater, than the degree in the denominator. then there is a slant asymptote. In order to find it, use long division and disregard the remainder. That's not how you spell that. Okay. So, for example, if you had like x to the fourth over x cubed, 4 is exactly 1 greater than 3, so therefore you would use long division and find that slant asymptote. Okay? And if there is a remainder, you just forget about it because it's so minuscule it won't affect the graph anyway. Step 7. It's a good time. Good time today. We're going to find the domain. That's not going away. Okay, but it's easier now because you've already found the restrictions throughout these other steps. So you look at the vertical asymptotes and the whole and then combine into interval notation. So the vertical asymptote is where it's undefined. The whole is where it's undefined. So therefore, those are the values of x that make that function undefined, which are those restrictions that we would find for the domain. Okay, so that's why you just have to look at those. Step 8, you're going to plot the found information. So we look at steps 1 through 7, and we plot everything we have. Step 9, you're going to find additional points. Okay, so this is where you're creating a table. And you're just choosing points that are going to show you the full shape of the graph. So create a table in order to see full shape of the graph. Okay, now that could mean that there's 3 points on your table. That could mean that there's 13 points on your table. It just really depends on the graph and what you need to see it. And then finally, step 10 is label completely. Okay, so we're going to label the function, the scale other than 1, all intercepts, all asymptotes, and a whole if there is one. Okay, those are the steps to graph. That's it. So now we're going to do some graphing. All right, this is going to go faster now. Yeah. Don't look at the time right now. Don't worry about the time. It's going to be fine. I know, it's hard not to, right? Okay, so let's do an example. So let's graph f of x equals, I would go to, well, no, that's enough room. That's enough room. If you have like 2/3 of a sheet left, you're good to go for space. If not, you might want to turn the page. X squared plus 5x plus 6 over x squared plus 4x plus 3. So all I'm going to do is I'm going to reference those steps that we just wrote out, and we're going to go through one by one. Now I want your homework laid out like this, and we're going to have the test laid out like this. So this is the format it's going to follow. I will list all the information that I want from you. So the first thing, we're going to look for a whole. Then we're going to find the y-intercept. Then we're going to find the x-intercepts. Then we're going to look for a vertical asymptote, horizontal asymptote, Slant asymptote. Domain. Additional points is going to be where we're going to make that table. And yes, the y-intercept and x-intercept have to be as ordered pairs because it's asking for the intercept. All right. So, if you have to reference those steps that we wrote out, go ahead. Okay? There's some rules on there we got to follow. The very first thing you do, no matter what, is you're going to factor the numerator and the denominator and see if there's a hole. Because if there's a hole, it's going to affect all of our other answers. So if you don't find it first, everything else can be wrong. Okay? So we're going to factor the numerator. That factors to x plus 2 times x plus 3. Then we're going to factor the denominator. So x plus 3 times x plus 1. Okay, do you see that there is a common factor? Okay, this x plus 3 is going to affect everything. It corresponds with the whole.
I'm excited.
Morgan's trying to copy off me.
Very much.
I get it, though. Who wouldn't want to copy off me? Okay, so now, take a look here. This x plus 3, it cancels, right? This creates the hole in our graph. So now, when I'm finding all this information, I am going to go back to my simplified version. Once it's canceled, I am focused in every single time on x plus 2 over x plus 1. That's what I got to go back to every time. Okay, so now we're going to find the hole. So to find the hole, you take the term that canceled, this x plus 3, you set it equal to 0, you solve, you get x equals 3. Now, remember, the hole is a point on the graph. So it's an ordered pair I'm looking for. So that means I got to find the y value. In order to find the y value, I have to go to the simplified version and I have to plug in x equals negative 3, because that's where the hole is. So you do negative 3 plus 2 over negative 3 plus 1. So that's going to give me negative 1 over negative 2, or positive 1/2. So now my hole is located at negative 3, 1/2. And I need to remember that on my graph, when I plot it, it's going to be an open circle, okay? Because this is a point on the graph that's undefined. If x equals 3, this becomes undefined. I mean, negative 3, it's undefined, okay? So now, when I'm finding all this other information, I'm going back to my green function here every time, okay? So now when it's time to find the y-intercept, what do you have to do? Plug in 0 for x, so I get y equals 0 plus 2 over 0 plus 1, so 2. Remember, it's an ordered pair, so that's 0, 2. Now I got to find the x-intercept. To find that, I'm looking at the numerator. I have to set it equal to 0 and solve. So now I'm going to take x plus 2, set it equal to 0. That gives me x equals negative 2. I'm going to write it as an ordered pair because it asked for an intercept. What if this said 0 or root? Then it would say what? X equals negative 2. Okay, so you got to know the difference between the two, what they're asking for. Are they asking for ordered pair and x equals? Yes?
Wait, why do you just do plus 3 to 0?
Because this term canceled.
But you don't get rid of the denominator.
No, because the denominator is going to make it undefined, which brings me to the vertical asymptote. So to find the vertical asymptote, you take the denominator and you set it equal to 0. So I'm going to take x plus 1 and set it equal to 0, giving me x equals negative 1. That means there's a vertical asymptote at x equals negative 1. We're going to have a dashed line there. This is a line that the graph can't cross. It's going to approach it, but it's not going to touch it. Evan, question?
So there's only one x-intercept?
In this case, yes, there's only one x-intercept. Okay? That's okay. You're going to see the graph's going to look very different than what we've done so far this year. All right, time to find the horizontal asymptote. So now I'm focused in on the degrees. So I'm looking at x plus 2 over x plus 1, and I'm focused in on the degrees. Now the degree in the numerator is 1, the degree in the denominator is 1. When the degrees are equal, what do? You look at the coefficients. So the coefficient in front of x is 1. The coefficient in front of this x is 1. So it's like I get y equals 1 over 1, which is just 1. So I have a horizontal asymptote at y equals 1. If this was like 2x over 3x, then I would have a horizontal asymptote at y equals 2/3. It's whatever the coefficients are in front of those terms. Yes?
All the asymptotes together.
Yes. Okay, now, that brings us to the slant asymptote. The rule for the slant asymptote is it has to be exactly 1 degree greater in the numerator than in the denominator. But that's not happening here, right? Here's the rule. If you have a horizontal asymptote, you cannot have a slant asymptote. Okay? Because the only way to have a horizontal asymptote is either to have the same degrees or to have the degree smaller in the numerator than in the denominator. Okay? So there is none here. You're not going to leave that blank. You're going to either draw a line through it or write the word none. Time to find the domain. So when I look at the domain, I'm looking at the whole, which the whole is at -3 1/2, and I'm looking at the vertical asymptotes, which in this case there's only one at x equals -1. That means that at these values of -3 and -1, my graph is undefined. When you write domain, you're writing in the restrictions, right? So the only two values that x isn't allowed to be is -3 or -1. So this is going to go from -infinity to -3, in union with -3 to -1, in union with -1 to infinity. All of the x values work, except for -3 where the whole was, and -1 where the vertical asymptote was. So far, so good? Notice there's not a lot of work to do for all of these pieces, right? You just have to remember how to find them. Now it's time to plot what I have. Okay, so I'm going to save the table because I don't really know what I want on my table yet. So I'm going to plot what I have. And I'm just going to use a scale of 1. For the labeling, every single thing that I found, I'm going to label. Okay, so the whole comes first, and it's at -3 1/2. When I put this on my graph, I can't just plot the point. I have to draw an open circle there because it's undefined there. So -3 1/2 should have an open circle, and I'm going to label the point. Okay, now that corresponds with the hole I found. Now I can't really tell it's open. That was stupid to highlight that. Oh well, it's done now. Okay, so the y-intercept is at 0, 2. I'm going to label that point. -2, 0, I have an intercept. Now, when I go to draw in the asymptotes, if you have a colored pen or a colored pencil or a marker or something, I would like you to draw them in colored. I'm going to have you to do that on the test too. It's just a lot easier to see them. So we have a vertical asymptote at x equals -1. Now this is a vertical line. We're going to draw all of our asymptotes in dashed, and we have to label them. Okay, so there's x equals -1. And now I also have a horizontal asymptote at y equals 1. So that's a horizontal line. I'm going to do the same thing, draw it in dashed, and label it. Y equals 1. Yes, you have to have arrows because it's a line, so it extends forever in both directions. Okay, so there's no slant asymptote, and the domain doesn't get graphed, right? We just see the domain. Okay, so now it's time to work on the table. Listen, this is not magic. You just pick the points it's going to take you to show the whole graph, all right? So looking at this, first of all, I want you to pay attention to where we have information. Do you see that I have information in the bottom left corner and in the top right corner? That means I'm going to have some curves going on there. Nothing's going to be happening in these other two quadrants here, okay? So I'm focused here. I'm going to choose values that are going to help me to see the full shape. So I really want to see how quickly do these approach the asymptotes. I know they're not going to cross. So I'm going to pick a point like -3/2. I'm also going to pick a point over here to the left, and I'm going to choose -4 because I already have it figured out. But you could choose, you know, -5, -20, it doesn't matter. All right, just something to the left. Then over here, I'm going to choose a -1/2 so I can see between that intercept and the asymptote what's going on. And then over here, I'm going to pick 1 because it's easy to evaluate. Now notice I only have 4 points on my table. I think that will be enough to show me the full shape. If you feel like you need more, then put more on there, okay? I am assuming you know how to make the table. So I'm assuming you know I got to take this x value, I got to go back to my original, I got to substitute it in, and I got to simplify to find y. Do you know how to do this? Yes.
Can we use the simplified
You
version?
can use the simplified version because it's going to cancel anyway.
So you
Yes.
put the x plus 3.
Right, you can always go back to the version that we canceled the whole. It's way faster, right? It's easier. Now, can I just fill in the table for you? Okay, so -3/2 is going to be at -1, -4 is 2/3, -1/2 is 3, and 1 is 3/2. So now I'm going to plot these points on my table, or I mean on my graph. I don't have to label these points. Just like I thought, I was within those two quadrants. Everything that we're graphing now is a curve, so there's no sharp points. It's going to approach the asymptotes, but it's not going to touch them. So watch how I draw in my graph. I put arrows on the ends because they extend forever in both directions, approaching those asymptotes. And the only thing I have left to do is label the function. And the labeling gets the original function before the canceling happened. So f of x equals x squared plus 5x plus 6 over x squared plus 4x plus 3. How are we doing? Good? Questions? Ready for another one? As ready as we're going to be.
I'm ready.
Yeah. Okay? Here we go. I'm going to move this. Okay, example 2. Graph f of x equals x squared minus 4 over x plus 1. Okay, we're going to find all the same stuff. So the whole, the y-intercept. This time I'm going to write 0 so we can see the difference. Vertical asymptote, horizontal asymptote, slant asymptote, domain, and our additional points. Okay, so the very first thing I'm going to do is factor. I'm going to see if there's a hole. So I factor the numerator into x plus 2x minus 2, and then my denominator is x plus 1. Is there a common factor this time? No, that means that there is no hole this time. So every time we're thinking about this, we don't have to look at a different function. We can look at the original or the factor version. The factor version is easier to work with. But we're going to write none here because there is no hole. Okay? To find the y-intercept, I just have to plug in 0 for x. So I have 0 squared minus 4 over 0 plus 1. So negative 4 over 1, which is negative 4. I write that as an ordered pair, 0, negative 4. How do you find the zeros? You take what? Just the numerator. And we set it equal to 0. So in this case, you get 2 zeros, right? At x equals plus and minus 2. You are not going to list, if I asked for x-intercepts, you would not list plus and minus 2, comma 0. Okay? They're ordered pairs. They represent points. You need to list them separately. Because this is just asking for zeros, though, I'm going to write x equals plus and minus 2, or you could say x equals negative 2, comma 2. Okay? It's a x equals this time rather than a point because it's not asking for the intercept. For the vertical asymptote, what do I have to do? Set the denominator equal to 0. So that means I only have one vertical asymptote at x equals negative 1. Is there a horizontal asymptote? So we're comparing the degrees now. The degree in the numerator is 2. The degree in the denominator is 1. 2 is greater than 1. When n is greater than m, there is no horizontal asymptote. But now, when you get a no for horizontal asymptote, you should be sending yourself a signal that you could possibly have a slant asymptote. The only way to get a slant asymptote is to have exactly 1 degree higher in the numerator than you do in the denominator. Isn't that happening here? 2 is exactly 1 more than 1. So that means there's a slant asymptote. So in order to find it, you have to use long division. So now we're going to do long division with our original problem. So I'm going to have x plus 1 on the outside, and on the inside, I'm going to have x squared plus 0x minus 4. I want that placeholder so I can stay organized. How do I take x and change it to x squared? Multiply by x, so then I distribute, I get x squared plus x. Remember, you are subtracting both of those terms. So I have left a negative x minus 4. Bless you. How do I take x and change it to a negative x? Multiply by a negative 1. When I distribute, I should get negative x minus 1. Again, I'm subtracting, so both of those signs change. I'm left with a negative 3. That negative 3 is the remainder, correct? But it doesn't matter. So you ignore it. You disregard it. It's so small on the graph, it doesn't change the equation of the line. Okay? So now, this represents a slant asymptote, which is a slanted line. Okay? This is a y equals equation. So I have y equals x minus 1 for my slant asymptote. When I go to find the domain, I'm looking at my hole, which there's none, and I'm looking at my vertical asymptote. So there's no hole, and x can't equal negative 1, right? Because it's the vertical asymptote. So if the only value is negative 1 that x can't be, then I got to go from negative infinity to negative 1 in union with negative 1 to infinity. I just have to jump over that vertical asymptote. Time to graph what we have. I'm still going to use a scale of 1. Now sometimes you can't determine the scale until you've, done the additional points. But I know that we can use 1 because I've already done this lesson today. So, there's no hole. My y-intercept says 0, negative 4. I have 2 zeros, one at positive 2, one at negative 2. Those are like intercepts on the graph. So I'm going to have negative 2, 0 here and positive 2, 0 here. I have a vertical asymptote at x equals negative 1. I'm drawing that dashed line in. I'm labeling it. There is not a horizontal asymptote. It's time to graph the slant asymptote. Now, the slant asymptote is in y equals mx plus b form. Remember, you plot the y-intercept first, and then graph your slope. It's a slope of 1, so up 1 over 1, up 1 over 1, or down and then to the left. Either way, you should be getting this line, which you should label.
And how do you know when to start when you're both on?
So it's in slope-intercept form, so you start at -1, and the slope of the line is 1. Okay, so right now I'm trying to focus on which areas of the graph should I see. Do you see in the top left there's something going on, in the bottom right there's something going on? So I expect to see curves that approach the asymptotes but don't touch them. I'm going to choose values that are easy for me to evaluate and that'll show me the shape of the graph. I chose -4. You could choose -3, you could choose -10, it doesn't matter. I chose +1. And I chose a +4. I only picked 3 points because I really know what's going to happen here. This is going to be a curve and this is going to be a curve. Okay, so I don't need that many once you start recognizing the pattern of the graph. So -4 gave me -4, 1 gave me -3/2, and 4 was 12/5. Very easily. So -4 is here. 1 -3/2 is here. 12/5 is like 2.4, so a little bit under 2.5. See how easy that was? Okay, so now I see my curves. And if you're not comfortable with it, then put more points on your table. We're going to approach those asymptotes. We're not going to touch them. There has to be arrows on both ends because these extend forever. Finally, label your equation. F of x equals x squared minus 4 over x plus 1.
What would be the point? Just put in -3/2, just
You could do -3/2. You could also do like -1/2 just to see where it's at. You just want to see that total shape, so it's what you're comfortable with. All right? Anything on your table doesn't have to get labeled on your graph. How are we doing?
We're still 18.
Oh yeah, having to fill them. We're going to shift gears now. We're not going to graph anymore. So, we're going to call this example 3.
so 2.6 if you get 10 in both graphs.
Yeah, it's like the same section. So there's no reason to do it in 2 days. We'll just do it in 1. Plus you're super smart, so you can handle it. And you love my voice, so you want to listen to me talk all hour. So, example 3. Let's go backwards. And smile while we do it. Okay, so now we're going to find the rational function which satisfies the given criteria. Okay, so we're looking for something that looks like f of x equals n of x over d of x. Some polynomial over another polynomial. That's what we're looking for. We're going to start out real easy. Okay? So let's say you've been given this information. The vertical asymptote is x equals -6. The horizontal asymptote is y equals 3. And the 0 is x equals 2. So I got to start out with something like f of x equals something over something. Okay, now we got to think about where did this information come from? Like, how did you find the information? So when I think about the vertical asymptote, how do you find a vertical asymptote? You take the denominator and you set it equal to 0. So if I was to take the denominator, set it equal to 0, and it produces x equals -6, what had to be in the denominator? X plus 6. If I have, I'm going to come back to the horizontal asymptote. If I have a 0 of x equals 2, where does the 0 come from? The numerator being set equal to 0. So if I was to get a solution of x equals 2, what would have to be in the numerator? X minus 2.
Why can't it be the
Because that would make it undefined. That would make it a vertical asymptote, where we want the x-intercept. We want a solution. Now, let's go back and revisit this idea of the horizontal asymptote. There's 3 types of horizontal asymptotes. There's one of y equals 0. There's a solution where there's absolutely no horizontal asymptote. And then there's one where you have equal coefficients producing a coefficient comparison, I guess, where you're taking the coefficient in the numerator, dividing it by the one in the denominator. Isn't that what's happening here? The only way to get a 3 is I had to have divided something, right? The degrees have to be the same. Well, can I see that the degrees are the same here, 1 and 1? So now what would have to go out front? A 3, right? And then that would produce 3x minus 6 over x plus 6. So that would be my final answer. Now, you could also have had like x, I'm sorry, like a 6x and a 2x on the bottom, right? So there's other answers you could get here, but it would finally simplify to a 3. All right, so there's multiple solutions here. But do you see where those pieces came from, how they kind of go back in, and we create this rational function? This is best case scenario. This is like a gift. It's probably not going to happen that easy, right? So now let's roll with a different scenario. Now let's say we're given the vertical asymptote is x equals 3. There's a slant asymptote of y equals x minus 2. And there's a 0 of x equals 4. This right here, this slant asymptote, this is not a gift. Okay, this is like worst case scenario. Yeah. Okay, so we're gonna deal with it in a little bit, but for now we're gonna focus just on the vertical asymptote and the 0. So let's think. We got to start out with f of x equals something over something. The vertical asymptote came from the denominator, so I should have a x minus 3 down here. The 0 came from the numerator, so I should have an x minus 4 here. How do you get a slant asymptote? The degree is exactly 1 more in the numerator than in the denominator. So how many terms am I missing in the numerator? Just 1. So I am missing something. I am missing some factor there. That's what I have to find. I'm going to find it using what I know about the slant asymptote. How do you get a slant asymptote? So once you know the degree is 1 more in the numerator than in the denominator, how do you find it? You find it through long division, right? Now what happens when we use the long division? We get down to the end, there's a remainder, and we do what with it? We throw it out. But now we got to welcome it back in, because that affects this whole problem. So really, this slant asymptote would look like y equals x minus 2 plus something over what I was dividing by. I don't have time for that. So now I have to figure out what that remainder was. How can I do that? Because here I have 3 variables. I have x, y, and a. I need to find a way to minimize it. But I can only minimize it using information that I already know. What about that 0? What does it represent? A solution point. Isn't it a solution point of this graph? Isn't it like x and y? Where x is 4 and y is 0? And if I could plug that in, couldn't I determine what a is? That's what I'm going to do. So now I'm going to take 0 for y and 4 for a. I'm sorry, for x. Okay, so let's see, this is going to give me 0 equals 2 plus a, so therefore a equals -2. Right? You have to subtract 2 to the other side to solve for a. Okay, so now my slant asymptote, the equation of it was really y equals x minus 2 minus 2 over x minus 3. How do you combine these things? Get a common denominator. Going back to that algebra review chapter, still coming back at us. It's like this is over 1 right now. So I'm going to multiply this piece by x minus 3. When I do that, I end up getting x squared minus 5x plus 6 minus this 2 over x minus 3, right? You get the common denominator, you have to distribute this, and then you still have that minus 2 left over. So this simplifies to x squared minus 5x plus 4 over x minus 3. What do you notice about x squared minus 5x plus 4? It factors. What does it factor to? X minus 4 times x minus 1 over x minus 3. Interesting. Because if we take this and we compare it to this, what did we just find? The other factor. That's how you have to find it. You have to think about the long division that happened to produce the solution. You have to find out what that remainder is, and then you're going to combine that into one rational function. So x minus 1 is the missing factor I needed. So my final answer is going to look like f of x equals x minus 4 times x minus 1 over x minus 3. Keep it factored because it's a lot easier for me to check. Okay? Yes?
Why is it 1 when
So it is one of the zeros. They just didn't tell me it was one of the zeros. Otherwise, I'd have all the information I needed. Okay? Any other questions?